this lesson, we'll be looking at what our textbook calls function rules. Some other books will just call it a function, but they call it a rule because it tells what's going to happen to the domain value before it gives you the range value, or as it gives you the range value. So what happens here, as you see in this figure, a domain value goes into the function. It's going to perform some type of rule or some type of function, and then it's going to give you your range value. So maybe this function here is going to be 2x plus 1. And so this function rule, we could say, is it multiplies the domain value x by 2, and then you add 1 to it. So just for example, if we pick the number 4 as our domain value, it's going to go into the function. The function rule is going to be performed, so you're going to take the 4, multiply it, so put the 4 in for x, multiply it by 2, and then add 1. So 2 times 4 is 8, plus 1 is 9. So out would come the range, which would be 9. So as you see here, we call this a function machine. It says values are chosen for x, put into the machine, manipulated by a function rule. In this case, 2x plus 1 was our function rule, and put out a corresponding y value, and that was 9. And so a function machine does a certain rule or does something to the x value, and it could be all kinds of different things. There's all types of different functions. So the next line here says a function rule is an equation that pairs each member of the domain with an element of the range. So it's an equation, and we've seen these before. The last thing here, if a function rule and the domain are given, then the entire function is defined and can be listed as a set, written as a table, graphed, or illustrated with a mapping. So what we have here, it says list the function as a list of ordered pairs. It gives you the domain, and this is your function rule. And so what we're going to do here is we're going to use just these elements here because our domain was given. So this is, we'll put -3 in, and I'll just list all of them, -1, 0, 2, and 4. And what we do here is we put -3 in for x. And so we'll have 3 times x, which is our domain value, that's -3 plus 2. And so -3 times 3 is -9 plus 2 is -7. 3, we put in that -1 in for x, and then add 2. So that's -3 times -1 is -3. Sorry, 3 times -1 is -3 plus 2 is -1. Put in 0 for x. And if you figure that out, you get 2. Putting in 2 for x, you get 3 times 2 is 6 plus 2 is 8. And putting in 4 for x, you get 3 times 4 is 12 plus 2 is 14. And so the directions say list the function as a list of ordered pairs. So this is a function, so it's a set, and we can list our ordered pairs. So we have -3 was paired with -7. The next ordered pair is -1 was paired with -1. Then we have 0 with 2. When we plugged in 2, our x value was 2, our y value was 8. And then we had 4 went to 14. And that is a list of ordered pairs. The next example here, it says graph the function y equals the absolute value of x. Now notice here there is not a domain listed. There's nothing listed here. So if there's nothing listed, we assume it's all real numbers. And that's like, it's an understood thing. Just like in English, when you give a command like get over here, the understood subject is you, get over here. So it's assumed all real numbers is our domain. So what we're going to do here is we're going to choose a few values for x, figure out what their y value will be, we'll graph them, and then we'll see if we see a pattern so that we can connect them and put the full function there. So let's put -2, -1, 0, 1, and 2. I always like to do some negatives, 0, and some positives. And if that doesn't help you figure it out what it looks like, then maybe you can choose some other numbers. But we take the absolute value of -2, which we know is just 2. And so let's just graph these right away. So we have the point -2, 2. Next one, the absolute value of -1 is just 1. So -1, 1. Absolute value of 0 is just 0. So we have the point 0, 0, which is our origin. Absolute value of 1 is 1. So we have the point x is 1, our y value is 1. And then the absolute value of 2 is 2. And so we look at this, it looks like it's going to be a v, and let's just see, will these other spaces fill in? If we put in absolute value of 3, it would be 3. Absolute value of 4 is 4. What about absolute value of like something in between here, like 1.5? Well, that's still 1.5. So what we end up having here is a v. And we'll look at the absolute value function in a later lesson, but this is what the absolute value function will look like, is a v. And so there is the function. Because a domain wasn't listed for us, we used all real numbers, and that's why we connect the points there. As we see in this next slide, we're going to be finding function rules. So it says you can often determine how a y-coordinate is related to its x-coordinate by examining a table of ordered pairs. Here we see several ordered pairs in this table. In example 3, we have -2 is paired with -6. We have the point -2, -6, -1, -3, 0, 0, 1, 3, and 2, 6. And we want to find some relationship between these. And so what we can do is we can take a couple guesses. For right now, we'll really be working with addition, subtraction, multiplication, and division. So we might think, how do we get from -2 to -6? And we might think, oh, well, we take that x value. And so we might think we have, maybe let's call our function f of x. Maybe it's the x value and you just subtract 4 from it. Because if you put in -2, to get -6, we could subtract 4. So that would work for our first point. Let's try our second point and see if this works. We would try f of -1. And we're hoping when we do this, that we'll get -3. So putting in -1 for x and subtracting 4, we get -5, which is not what we want. So that is not correct, so we don't want to use that. We can get rid of this guess right here. So we'll take another look at this. -2 to -6, well, that's multiplying by 3, so maybe our function is f of x is just 3 times the x value. And it works for -2, so if we did -2, 3 times -2 is -6. Let's try it for our next value of -1. -1 is 3, put -1 in for x, and you get -3, and that works. And we can think through the rest of these. If we put 0 into this function, we would have 3 times 0 is 0, and that's what we want. Putting a 1 into the function, 3 times 1 is 3. And the last one, f of 2, putting 2 in for x would give us 6, which is what we want. So this equation right here is the function rule for that table. The next one is a graph, and in this graph we have a line, and so what we might want to do is just find some points on this line so we can help determine the relationship. So we're going to go ahead and pick out some of these important points, and maybe they can help us figure out what our relationship is. So there's an infinite number of points along this line. We're just going to look at these specific ones. So we have this point is -2, 0, and then we have 0, 1. We have the point here that's 1, 1.5, 2, 2, and 3, 2.5, and then the last one I marked there, it's not the last point on there, is 4, 3. And noticing especially these last 4, and this is going to be a learned skill that you have here, figuring this stuff out, and we'll actually look more specifically at lines later. But you want to figure out what's going on here. And I'm going to look right here for a minute because I counted up, actually I could have gone all the way down. Sorry, I wrote this wrong. This was 1.5. Could have gone up to here. We counted up by 1. 0, 1, 2, 3, and 4. And over here, we went up by halves. 1, 1.5, 2, 2.5, 3. That tells me that I'm going to be, when I think of my rule, I'm going to be using the idea that, so that it goes up by halves. So that's going to be, I'm going to take half times my x value. Now, maybe this is it. I'm going to try a couple numbers. So if I put g of 0 in here, g of 0 would be 1/2 times 0, which gives me 0. So this point would be the point 0, 0. I don't have the point 0, 0. I have the point 0, 1. So that is not the correct function, but again, I picked this 1/2 x because I'm going up by halves. So I'm pretty sure that's right. So I have a 0, I have the point 0, 0, but I wanted one more than that. I didn't want 0, 0, I wanted 0, 1. So what I'm going to do is I'm going to change my guess here, and I'm going to put 1/2 x plus 1. And we're going to go ahead and see how that turns out. And let's try some values with this one. So let's try g of 0, and we're hoping to get 0, 1. So putting in 0, we get 1/2 times our x value, which is 0, plus 1. And that, in fact, is 1/2 times 0, 0, plus 1 is 1. So that's what we wanted. This gives us the point 0, 1. Let's just try g of 2. So I have 1/2 times 2 plus 1. Well, 1/2 times 2 is 1. 1 plus 1 is 2, which gives me the point 2, 2, which is what I wanted. And we can try another one just to make sure. Let's do g of 3, because that gave us a 2.5, and we haven't had a half yet here. So let's put that in there. So 1/2, and we're putting 3 in for our x value. So 1/2 times 3 plus 1. Hopefully you're realizing I'm putting all these numbers when I plug back into this function here. So this is 3/2. You can put this over 1 and think that's 3/2, and 3/2 is 1.5. Plus 1 is in fact 2.5, which gives us the point 3, 2.5, and that is what we wanted. So this is the correct function for us. G of x equals 1/2 x plus 1. Let's jump down to our last examples here. Find the function rule for the ordered pairs given in the graph. And so what we have here, let's start at the far left. We have -3, 9. So I'm going to actually make a table here. X and our function, let's just call it f of x. We have -3, 9. We have this point, which is -2, 4. We have -1, 1. We have the origin there, so 0, 0. We have 1, 1, so x is 1, f of x is 1. We have 2, 4, and 3, 9. So thinking through here and looking at this, we have -3 is 9, but so is 3. So we have some repeats here. -2 is 4, 2 is 4. -1 is 1. So thinking through this is something that you should end up being able to recognize. And this might be the first time you've seen it, but we're really just squaring the x value. -3 squared is 9. -2 squared is 4. So find the function rule. Well, f of x is just, you square, the rule is we're going to square the x value. So we're going to take x squared. Now these are individual points, so we do want to list our domain. Our domain ends up being these numbers up here, so -3 all the way up to 3, those integers, and we get that there. So that would be the function rule there. So being able to recognize squared numbers is a good thing. In example 6 here, we see Caitlin is comparing 2 cell phone plans. Plan A is $47 a month with unlimited minutes. So that just means, I think all of you know what that means. You can have as many minutes as you want, and you always pay $47. If you have 5 minutes, it's $47. If you have 5,000 minutes, it's $47. Plan B is $28 a month and then 4 cents a minute after that. So state a function rule for both plans. So we're going to have Plan A and we're going to have Plan B. Graph the two functions, then determine which plan is better for Caitlin if she usually uses 480 minutes a month. So Plan A, we'll just call this A of x. So we know that represents Plan A, where x is going to equal our number of minutes talked. And that's going to be the same thing in any one, or number of minutes used. Number of minutes. And what's interesting about Plan A of x has nothing to do with how many minutes you talk. You pay $47 no matter how many minutes you talk. So this is, A of x is just $47. It says graph it, and so we'll do that. This is an interesting graph. So if we speak 0 minutes, it's $47. If it is, let's say this is 10 minutes, $47. If it's 20 minutes, $47. 30. So all the way up, this graph is going to be a horizontal line through 47 because it will always be $47 per month. Plan B is a little bit different. You definitely pay $28 a month all the time. You pay at least $28, but you pay an extra for each minute that is used. And we know that we pay 4 cents a minute. So if we speak 1 minute or use 1 minute, it's 4 cents. 2 minutes would be 8 cents. 3 minutes would be 12 cents. And the way that we're finding that is we're just putting 0.04 times the number of minutes that we speak, which is still x. So number of minutes. And so there is our function for that. So this one's a little different in our graph. If Caitlin uses 0 minutes, she's going to spend $28. If she uses 10 minutes, I'm still going to count by 10 just so we see this. If we use 10 minutes, 10 times 0.04 is 40 cents. So at 10 minutes, we're going to be at $28.40. So up a little bit from there. So there's at 10 minutes. 20 minutes, if we use 20 minutes, 20 times 0.0 is 4, so we're going up a little bit from there. And so this is going to slowly increase. If we put 30 minutes in here, 30 times this is $1.20, and so it's going to go up a little bit more. But we have a line that goes through 28 and then is increasing by the number of minutes that are used. So there's a couple simple graphs. This one's horizontal, this one is sloping upward. Determine which plan is better if Caitlin typically uses 480 minutes a month. Well, what we're going to do is we're going to compare our two functions. We're going to take A of 480. That means for plan A, she's using up 480 minutes. Well, we know that if she uses 480 minutes, it's $47 no matter what. Now for plan B, it's going to be $28
plus the 0.04 times the 480. Sorry, that might not be very legible. So that's the 0.04 times 480. I'm using this function right here. And we need to figure out what that is. So that's 28. And 0.04 times 480, I have the space up here, so let's multiply. And so we get 0, 2, 3. And move the decimal, so that's 19.20. So that's an extra $19.20. Add those together. So the 28 original plus the extra $19.20 is $47.20. So it is very close. It seems like she should just go ahead and use the Plan A where it's $47 a month. It wasn't a whole lot more for Plan B. So there you go. Plan A would work out better for her. She would save 20 cents a month.